Okay, guys, welcome to the test 4.2 Reteach. I'm going to go through a version of the questions from the test, and you'll be able to use this to earn a reassessment on the test and get another opportunity to take it and do better. Okay, so looking at the first question, we're asked about the domain, and we're talking, this is an implied domain question. So this is kind of a pre-AP question, so you'll see I'm going to work this out, and then I will show you something for my academic guys out there as well. Okay, so in this question, you can see we've got square root 25 minus x squared over x minus 5. Now, two issues can occur in this problem. The first rule that we want to note is no square roots of negatives, okay? And at the bottom, we're dividing, and we can't divide by 0, right? So we'll just say we can't do that. So we need to make sure that our domain follows those rules. And we'll just start at the top. So if we can't take the square root of a negative, 25 minus x squared must be positive, which means it is greater than or equal to 0. And we can start to get this all by itself. We're going to get 25 is greater than or equal to x squared, right? Just moving that x squared to the other side. And I can take the square root of both sides. So when I take the square root, now as you know, this normally leads us to a positive negative situation. Now with the greater than or less than symbol, this is going to lead us to a little split in our function now. So we're going to have, well, the regular version, 5 is greater than or equal to x, right? No, nothing changed, just the square root was taken. And then we have the negative version. So negative 5 is less than or equal to x. And you're going to notice that this sign is definitely flipped from what it was originally, right? This one is the opposite of what I started with. So just keep that in mind when you make that negative side. It is going to be flipped. Now, with this, let's put it all together. X is greater than negative 5 and less than 5. And if I put those two together right now, I've got this. It's between negative 5 and 5. Or we could write it as negative 5 bracket with 5 bracket. Okay, in between those two numbers. Now, looking at the bottom, we already said we can't divide by 0. So we'll take care of the bottom part right now. And that's going to say, hey, x minus 5 does not equal 0. So x should not equal 5. And that should not equal 5 is going to kind of adjust this 5 over here. So when I take away, hey, it can't equal 5 anymore, my final answer leaves me with negative 5, 5, with a parentheses, right? Because we're not equal to that 5 anymore. And this domain was what we were looking for. And if you wrote this out the other way, like the answer choices here are showing you, well, x is greater than 5, less than 5, so on and so forth, you would have written this as from negative 5 to 5 with no equals anymore, right? So kind of so you can see it in two different forms. In green are what your final answers would be. And I went ahead and highlighted that answer choice for you up at the top. Okay. Now, my academic guys, you'd have something a little bit simpler than this. You're going to just see, so you might have seen something like this on your test, right? And these are kind of the two types of problems I showed you for the academic test. All right. And again, the same two rules apply. So this can't be equal to 0, right? We can't divide by 0. So x minus 5 does not equal 0. So x does not equal 5. And we just added that 5 to the other side. Okay. And for the square root problem, same approach as what we talked about before too. No negatives under that square root. So what have we got here? X minus 5 is greater than or equal to 0. It's positive. We move that 5 over. And boom, here we go. We've got x is greater than or equal to 5, right? So this might be something that you could have seen on the academic test. either a division problem where it does not equal 0 or a square root problem where you'd have to be greater than or equal to 0. All right, question 2 is a piecewise functions question. We were asked to evaluate g of 7, so I just need to figure out what that's equal to. And the first step to this is we're going to take our input, which in this case is 7, and I need to figure out which of these three equations it should go with, right? So I ask myself first, is 7 less than -1 if I filled it in that first thing, right here? And you'd say, no, that's not right. There's no way that 7 is less than -1. Well, is 7 in between -1 and 3, right? Does it follow that rule? You'd again say, no, that's no good to me, okay? 7 is greater than 3, so I'm going to say, yes, that's the one, okay? And now all I have to do is take this equation and plug in 7 to it. So we've got 7 minus 3 squared, and that's going to be 4 squared or 16 as my final answer, right? So very simply, figure out which equation it belongs to, right? The right-hand section is the rule that you need to follow, and then the left is where you're going to plug in your number, okay? Now, if it doesn't fit in any rule, you're going to say undefined. Okay, so if you see a problem and you're like, wait a minute, this number that they gave me, that 7, didn't belong to any rule, you say that it's undefined. All right, moving right along into problem 3, and it asks if these points make a function, right? So key thing for a function, we're going to look at our x values, and we're just going to look for, hey, are these all unique x values? Like, do I repeat any of them? And if we just kind of scrutinize this carefully, you're going to notice, wait, there's two ones, and they have different y values, right? That's a repeated x, and this is not a function because that x repeated. Okay, anytime you do that, this would fail the vertical line test, and it has multiple answers for the same x. That's no good to us as a function. Okay, question 4, we've got another piecewise function, right? Evaluate f of 4. If we get a fraction, we should make it a decimal, just so that it's easy to put in the computer for us. But let's see what we get. So again, f of 4, I need to figure out which one of these categories 4 fits in. So 4 is, first of all, not less than -1. It is not less than 4 and greater than -1. That does not have an equals to, so we're not going to include that. But this one right here, this one's good. 4 is greater than or equal to 4, yes. So let's plug it in over here. 1 over 4 plus 3, okay? And we could do it by hand. We can make this into 12 over 4, 13 over 4, which leads me to 3.25, okay? And even if you just said, hey, that's 3, this is 0.25, and you get that. So we could do it by hand, we could do it with a calculator, but that's our final answer. Again, figure out which rule it fits into, then plug the number into that equation. Okay, question 5, we want to check where the function is decreasing. So first of all, remember, decreasing means your graph must be going down from left to right. So I'm going to highlight these sections on the graph. So here's my first one. Here's another one. Okay. Here's another one. And finally from up here down all the way there. Okay. So now that we've highlighted those, let's mark those out as our answer choice regions and see what we get. So starting from, it looks like, remember, these are my x values, okay? Intervals are going to be x values. And we've got from -12 until -8, okay? The next one is this middle section right here. And it's a little bit odd, but maybe it's from -2 until 0. And then we've got our section here from 2 until maybe 6. And finally, we've got another one from, it looks like 7 until +12. Okay, so in terms of answer choices, you would have checked all four of those boxes. Those are the four sections I see that are decreasing. Okay, and if you ran into an answer choice where they were all put together, you would put that union symbol or the U in between each one, right, and go in order. Okay, question 6, we're looking at that same graph again from the previous question, and this time I want to find out what f of negative 2 is. So I have the x value, they've already told me. Okay, your x value is negative 2. Can we figure out what that y value is? So I'm going to come over to negative 2, and I'm going to mark, hey, look, here are the two spots on my graph at negative 2. Now, only one of these can be my answer. If you look closely, you'll notice that this top one has an open circle, right? So open circle means that it's not one of my points on the graph. And that means that can't be my answer, right? So I have to go with the bottom point that's filled in. And I'm going to go ahead and say that f of negative 2 is equal to 3, which is my y value here. Okay, so they told me the x value is negative 2, and I found my y value from the graph at 3. Not 7. 7 is an open circle, so that one's no good to me. Okay, question 7. Again, we're trying to see if this is a function. If input-output confuses you, remember these are just x and y's. So again, rule is no repeat x's. And if we look at this table for a second, you're going to notice 0, 2, 5, 4, 10. They're all okay. They're not going to repeat, and I'm just going to call this a function and go about my merry way. All right. Question 8 is talking about symmetry. So with symmetry, remember, we're going to try and test it by comparing when I plug in negative versions of certain things. Okay, so I'm going to start with writing out my original function on one end of my t-chart. So over here is my original function, y equals x to the fifth minus 3x squared plus 2x. And what we're going to do first thing, let's test the three types of symmetry. Okay, so my first one is going to be x-axis symmetry, and for that I plug in negative y. Okay, so we're going to take this equation, and everywhere that I had a y, I'm just going to plug in a negative y. So here we go, negative y equals x to the fifth minus 3x squared plus 2x. And I notice my negative is not canceling out. There's no exponent there. And if I even get that y by itself, we're going to notice that this equation is not the same as what I started with. And that means that this function is not going to have this. So I'm going to put a little x there just so that we know that one is no good to me. And then what we'll do is we'll go to the next type of symmetry and we can test the next one. So next symmetry I've got is y-axis symmetry. So y-axis symmetry, again, is going to use the opposite variable, right? Axis is y, so my variable, I'm going to plug in negative x, okay? And let's see what we get when we plug this in. So here we go. I've got y equals negative x to the fifth minus 3 negative x squared plus 2x. That x is negative. And here we go. Let's see what our final product looks like. So remember, odd exponents are going to keep those negatives. So this first one is going to stay negative. This negative gets canceled out over here, so we've still just got minus 3x squared and minus 2x now. Again, this does not match what I started with, right? I'm looking for something to match my original. This one is no good to me. These negative signs are completely wrong, and so that means this is not going to have the y-axis symmetry. Now, if your function does have y-axis symmetry, remember that also means that this function would be even And the third case that we're going to look at is origin symmetry, which is both negative x and negative y. All right. And we also note that functions with that type of symmetry are considered to be odd functions. Okay. And so here we go. We'll just set it up the same way. Okay. Negative y equals negative x to the fifth minus 3 negative x squared minus 2 times negative x. All right. And it seems like a lot, but honestly, we've already simplified both sides once before. So here we go. I'll just start with the right-hand side and just kind of following exactly what I just saw. And you're going to notice, again, even when I get the y by itself, by moving this negative to the other side, x to the fifth plus 3x squared plus 2x. And we're going to notice I'm still off by a negative, right? Specifically this middle one. And I'm going to again say not the same. So this one actually has no symmetry and not even or odd, right? So I'm going to just go ahead and say this has none in terms of symmetry or being even odd. And we'll see an example later that has some type of symmetry. Okay, so this next one is another symmetry question. Let's see how this one works out. We're going to set up the t-tables the same way. Okay, so first thing, we're just going to write out the original function. And now that I've noted that, let's start with our x-axis symmetry test. And remember that one, I always plug in negative y. Okay, and the goal is to see, hey, does it match my original equation? Okay, so I'm going to write it with that negative y plugged in there. And here we go. We've got negative x to the fifth plus x cubed minus 3x. Again, I didn't change anything with the x's. I only changed that y to being a negative. Now take a moment and you tell me, do you think this is the same as what I started with? If you're not sure, move this negative to the other side. So we'll just divide it by -1. And you're going to notice, wait a minute, this is not the same as what I started with. And that means this function does not have this type of symmetry. Okay, no x-axis symmetry here. And we can go ahead and do the next one where we test for y-axis symmetry. And remember, the y-axis symmetry test is the same as being even. Okay, so those two always go together. If you pick one of those, you should make sure you pick both answers. All right, let's see how that equation looks. We're going to say negative x this time. So here we go. Y equals negative x to the fifth plus negative x cubed minus 3 times negative x. And we're going to see, wait a minute, these negative signs, because of odd exponents, they're going to stick around. And here we go, x to the fifth minus x cubed plus 3x. And we're going to say, hey, this does not match my equation again. So again, we're out of luck here. Okay, so this function is not even, it doesn't have y-axis symmetry, and it doesn't have x-axis symmetry. Let's test this last one now. So we're testing for origin symmetry. Okay, let me push this to the side for a moment. Okay, and let's look at our origin symmetry. So this time we're going to have negative x and negative y. So here we go. Negative y equals negative x to the fifth plus negative x cubed minus 3 negative x. And we'll go ahead and start simplifying the right side, the one that's kind of bigger. X to the fifth minus x cubed plus 3x, and I've still got negative y over here on the left. Now, when I move this negative over, we're going to get that y by itself, and we're going to get this. Y equals x to the fifth, which is negative, plus x cubed and minus 3x. Okay, and this equation, wait a minute, is actually the same as my original. And if we scroll it to the side a little bit, we can see that this equation and the one that we came up with here are both the exact same. All right, and what that means for us now is that we can say this symmetry is correct, and my function has origin symmetry, and that also means that this function is odd because these both go together, right? Origin and odd functions go together. So in this case, this function has origin symmetry and is treated as being odd because when I simplified it, the answer I got here was the same equation that I started with. All right, question 10. Using the graph, let's find out if f of x equals 1, right? Or what is f of x equals 1? So I'm going to solve for my x value here. And I'm going to start by saying, hey, I know my y value is 1, right? So f of x equals 1. This is my y value. So let's highlight some points where this equals 1. So right here, I'm going to just draw a line across the 1. And you can see there are two spots where my line meets. And here we go, right here and right here. So what x values are those? Very simply, just negative 1 and 1. So x is negative 1 and 1. Okay, so there were two answers here. All you had to do was find the x values this time. They gave us the y value already. Okay, same graph, but this time we're asked, hey, what is the range of this function? So range, I always like to measure from bottom to top. Okay, so here's my lowest point right here. So I know I'm going to start from 0. And I can follow it to the right and I get stopped at 1. But if I look to the left instead, you can see we could just follow this pretty easily upwards. And I hit an arrow towards infinity, right? That's kind of my breaking point. But I've already caught all of this stuff, all of these values right here and right here, got caught in this upward motion. So I'm already set there. And I hit an arrow, which means I'm going towards infinity. So we've got bracket and parentheses from 0 to infinity. Don't get thrown off by these little gaps on the right-hand side. We covered all of those values with the left-hand part, right? So like, for example, this little section right here that's missing. Look, you already covered that section on the left, so you don't have to even think about that missing section. All right, is this a function? I'm hoping that all of you guys giggled a little bit and just immediately drew that vertical line and said, this fails the vertical line test. And so this is not a function. All right, so question 13, we want an absolute minimum of this transformed function. Okay, so this was again like a pre-AP type of question. And we did something similar for my academic guys. You just didn't have the transformation. So first thing, we're going to find the absolute minimum on this graph. And let's mark it real quick. So if we're looking for the lowest point, boom, here it is, right? So we would have just said, hey, where's my minimum? 0, comma, -2 is my minimum. But this asks for the transformed version. So my academic guys, you would have found this minimum and been very happy. This question asks us for some transformations. So let's think about what's happening to my function. That +4 inside the parentheses looks like we're going left 4 spaces. And that +5 at the end looks like we're going up 5 spaces. So we're going to take our minimum and we're just going to transform it based on this information. So let's go left 4 spaces. So first thing, I was at 0, and I'm going to go left 4 spaces. Where am I now, right? We're going to subtract 4 from 0. So 0 minus 4 gives me -4. And then we can shift our graph up 5 spaces. So we're going to take -2, and we're going to add 5 to it. So here we go. We had -4, and this is going to give me 3. And this right here is the new absolute minimum after you do these transformations, okay? So my academic guys, you were not doing the transformations. That's all you needed to do was identify that minimum. Pre-AP, you guys were going to transform it, so you would have shifted it 4 spaces up and 5 spaces to the, or sorry, 5 spaces up and 4 spaces to the left. Okay, let's take a look at this graph and find the interval where f of x is greater than 0. Again, intervals are x values. So we're looking for a section of my graph that is above 0, okay? And I'm just going to highlight it. Look, here's my section above 0. It's above the x-axis, so that is at 0. Let's figure out where that section is. So it looks like it starts from right here, -1, and it's going to go until 2. Right, again, I'm looking at the x value, so that's where it starts and ends. And we're going to bracket this because these were both filled in circles. So this region is greater than 0. Okay, and the last question here, we've got a domain question. So domain, I'm going to do from left to right, starting from low to high, right? So let's find our domain. And if I start over here, it looks like this is at -4. And I'm just going to keep kind of following it along my graph until I hit some kind of break. So here we go. I hit a break here at 2. And my question is, do I need to actually stop in my domain after reaching -4, starting from -4 and going up to this point? And the answer is no, because I've got this filled in circle here, right? At the bottom, you can see that circle was filled in. And because I have a filled in circle, I have a value for that point. We're just going to keep going, and I can keep following it along until I reach the end of my graph at 4. Okay, so we do not need to stop here. Okay, and the reason we don't stop is because we have a filled in circle. And that means we don't have to break our domain. Okay, and so that's all there is to it. If there's a filled in value there, anywhere, even if that point hadn't been on either of my lines, if it had been above or below all of that, we would still not have to stop. Unless there's only open circles or there's some kind of separation between the lines, we don't need to stop for the domain. Okay. All right. Hope this was helpful to you guys. Remember, make sure you go back, review the problems that you really struggled with, and fill in the reflection portions on that correction sheet. Okay.